What's up everybody and welcome to the channel. Today I want to talk about a grid snapping and managing system that I've been using in a couple of my own projects, and it's actually pretty simple to set up and very versatile, so you can do all kinds of things with it. And I thought it would be useful to show it to you guys if you want to build something like a city builder or an RTS game or anything like that, then this could be pretty useful. So first of all, let me show you what we're going to do today. This is the project that we're going to make. We will simply have a grid marker that snaps to certain locations on the grid. So we're not going to draw an actual grid in the level. And we can define the grid size. And on the top left, you can see some debugging here. So you can see the location of the grid marker and the actual coordinates of the grid marker. And those are unique coordinates. So we can use those to save information about a specific tile, for example. And let me show you. So we can, for example, build a house over here. And if I left click on an empty tile, it will say no tile info found. And if I click on the house, it will actually identify it as a house. And I can delete it and then left click, and then again there's no tile info found. So that's something that I'm going to show you how you can set it up. And it's really not too hard, to be honest. And there's also a few things that we can specify about the grid. So we can change the grid size very easily. For example, I can increase the grid size and then also change the line thickness and the color of the marker just inside of the blueprint over here. And you can see now we have a grid size of 250 and we have a green marker. So that's a few things that we can specify about the grid. And there's also another project that I wanted to show you. So I've used this in my arcade racing game that I recently put up in the Discord for the track editor. And in this case, it's simply a snapping system, so you can use it to easily build straight roads, for example. And in this case, I also added a height, so you can increase and decrease the height of the actual track and just make it easier to build stuff. And in here, there's also things like props that you can build, for example, and you can select those. So yeah, all kinds of different ways that you can use it. And this project is available in my Discord for free, so you can download it and check it out if you want to. So you can see how you can use it, for example, but there's all kinds of other stuff that you can do with it as well. So let's start today's episode and let's start building our grid snapping and managing system. So first of all, let's create the project. For this one, I'm going to use the top-down template simply because we already have a top-down view in here and there's a player controller ready in the project to use. So that saves us a little bit of time, but pick whatever project you want. So let's call this the Game Dev Raw Grid project. And by the way, I'm creating this in Unreal Engine 5.5. But this should work in any version. There shouldn't be any issues creating it in a lower version as well. So it's creating it on my other monitor. It shouldn't take too long. There we go. So the default project in here. And first of all, let's start by creating a new folder. And let's call that grid. Inside of the folder, the first thing we're going to create is the actual grid marker. So create a new blueprint class, and that's going to be an actor, the BP grid marker. And let's open it up. So we want to add a box collision in here. So let's look for the box collision component. And let's call this our grid marker collision. So I'm going to replace the root with the actual box, and then we're going to go to the construction script. Let's drag in a reference to the grid marker, and the first thing we want to do is set the box extent. So that's the size of the box. Plug it in, and we want to right click the extent, and we're going to split the struct pin. So I'm gonna use a fixed value for the Z and make the box 10 high, but you can play around with it, whatever suits your level or your project. Then let's drag off the X, promote it to a variable, and this is the half grid size. And we also want to plug that into the Y value. With this selected, we're going to say instance editable and exposed on spawn. Then we're going to drag off the box collision again, and we want to set the line thickness. Plug it in, and again we're going to promote this to a variable, so that's the line thickness. And that's instance editable and exposed on spawn as well. Then the third thing we're going to do in here is set the color. So drag off the box again and set the shape color. And this is the only thing that might not work in every version of Unreal, to be honest. So in older versions, you sometimes simply need to set the color over here in the advanced section with the box selected. But in 5.5, we can actually do it directly in the construction script. So we want to drag off the shape color, again promote it to a variable, and that's our, well, let's call this marker color. And that's also instance editable and exposed on spawn. So that's good to go. The last thing we want to do is drag off the collision box again, and we're going to set the hidden in game. And we want to keep that false so we can actually see it inside of our project. So compile and save, and that's the entire grid marker. And I'm not sure why it disappeared in here, but I'm gonna guess everything is still okay. Oh, that's because we don't have an extent, so it's going to run the construction script. So that's fine. So that's the grid marker. The next thing we want to do is create a struct that we're going to use a little bit later, and we just want to have it in place. So I'm going to right click in an empty spot and then go to blueprint and create a new structure. Call this s_grid coordinates. Open it up. The first value is going to be the x value, and we're going to turn it into an integer. And then we're going to add a second value, and that's the y value. That's also an integer. So save the structure and close it. And at this point, we want to create the actual grid manager, and I'm going to create it as an actor component. So we can simply add it as a component to any player controller, and we can use it in multiple projects. So I'm going to right click, create a new blueprint class, and in this case we're going to select the actor component. So call this our BP grid manager, and let's open it up. So the first thing we want to do is get a reference to the player controller where we added it to. So in an empty spot, we're going to right click and we're going to get the owner of this actor component. And then we can cast that to a player controller. So we don't need to actually cast it to a specific class. If you have a top-down player controller or something like that, we only want to use some default stuff from the normal player controller, so you can cast to this class, and that should be fine. Drag off here, promote it to a variable, and that's our owning player controller. There we go. And then we want to spawn our grid marker as well. So we're going to drag off and spawn an actor from class. We're going to select our BP grid marker. And we don't really need to spawn it in a specific location, so we can split the struct bin so it won't give any errors, and that should be fine. Then we need to set up the variables that we exposed on spawn. So we're going to drag off the half grid size, promote it to a variable again. And this is the actual normal grid size. So we want to disconnect it, and then we're going to divide this by 2, because for the extent we need the half grid size. So then plug it in over here. The grid size, we're going to not expose it on spawn, but we're going to make it instance editable. Then drag off the line thickness, again promote it to a variable, and make that instance editable as well. And for the marker color, the same thing, drag off, promote it to a variable, and make that instance editable as well. There we go. Now we want to go to the return value, and we want to promote this as a variable as well. And this is our actual grid marker. So BP grid marker. So we have that stored as well. Now we want to go to our event tick over here. And the first thing we want to do is get our owning player controller. And from this, we're going to get the hit result under cursor by channel. So the upper one over here. And from this hit result, we're going to grab the actual hit result structure and break it. Expand it, and in here we have the location, and that's what we need. So we're going to drag off the location and break the vector. So we end up with an XYZ value. And for the X and the Y, we want to divide those by the grid size. So we're going to drag off our X value, divide, grab our grid size, plug it in. Then we can copy and paste this and do the same thing for the Y value. So I'm not going to do it for the Z value in this case, but you could do that as well, depending on the needs of your project. Then we're going to drag off here and we're going to round the float. So it will round it to an integer and get rid of the decimals. So copy and paste it and do that for the Y value as well. And this is the actual coordinate that we're going to use for our grid. So we're going to create a new variable and call this our grid coordinates. And for this, we're going to use the structure that we just created. So that's s_grid coordinates. And we're going to drag in a setter for that one and plug it into event tick over here. So if we left click over here, we can split the struct bin, and then we can plug in our X and our Y values in the coordinates. And at this point, we also need the actual location of the grid marker. So we're going to create a second variable, and that's our grid location. And that's a normal vector. So we're going to drag in a setter for the vector over here as well and plug it in. Right click the grid location and again split the struct bin. So first of all, let's grab the Z value from the hit result and plug that directly into the grid location setter. Like so. And then again, we're going to split the struct bin of the structure over here. And for the X and the Y value, we need to multiply those again with the grid size. So let's multiply it. Grab our grid size and plug it in. And do the same thing for the Y value. So copy and paste it and plug that in as well. And we can plug those into the grid location over here. And then the last thing we need to do is grab our grid marker. And we're going to set an extra location. Plug it in and simply plug in our grid location over here. So this should make the main part of it work. We can add a little simple debug as I showed in the beginning of the video as well. So we could say print a little text over here. So not a string but a text, and then we can drag off the text and we can do format text. And in here I'm going to say first let's do the coordinates. So I'm going to say coordinates. Oh, there we go. And then I want to do a normal bracket open. Then I'm going to do open curly bracket A and close a curly bracket and do the same thing for B. So curly open B and curly closed, and then a normal bracket to close it off. So that's not confusing at all. If we hit enter, the A and the B will be a pin over here that we can use. So now we can grab our grid coordinate, right click, split it, and simply plug them in over here so we can print them to the screen. And for the duration, I'm going to use the delta seconds over here so it won't flush our screen. So plug the delta seconds into the print text node. And then we can do the same thing for the grid location. So let's copy and paste this. And over here, I'm going to say location. And then we actually only need an A pin. So I'm going to do curly bracket open, A curly bracket closed, and grab our grid location and simply convert it to a string. So vector to string, and plug it in over here. And again, grab the delta seconds and plug that into the duration. Compile and save. So this should be pretty much good to go. Now we want to add it to our player controller. So let's go to our top-down folder and look at the blueprints in here. Open the top-down controller, and in here for the component we're going to add our grid manager. Here we have it, and then on the right side we can define the grid size. So I'm going to use a grid size of 100 and then a line thickness of 4 and make the grid red. So not the grid but the marker. So let's select a red color and hit OK. So now if we compile and save, we should be able to test this and it should work. So over here we have the grid marker, and in the top left we have our little debug, so we can see the coordinates and we can see the location. So that part is working. And we can increase or decrease the grid size. So I could say give us a grid of 200 for example, and make the marker pink or purple, whatever. And then things will change. So now we have a bigger grid marker and a purple marker. So that's the beginning of the project, good to go, and that's already working. So that's actually the core of the grid marker and the grid system. So now just to show you how you can use it, for example, first of all, let's start in our player controller. So I'm gonna go over here to the set destination click event, and I'm going to disconnect all of this stuff so the actual pawn doesn't keep moving around, because that's just annoying. And then if we left click, I want to get the information from a certain tile, and for that we can actually use a mapping, and I forgot to create it, so we need to go back to our grid manager, and we can create a new variable and call this our grid information. So on the left side over here, click the little down arrow, and we're going to change it into a map. And then we can select the first value over here as our grid coordinates. And for the second value, there's multiple things you can do. For example, you could simply use gameplay tags. So if you have gameplay tags set up in your project, you can change it to a gameplay tag container. So then you can map the coordinates to gameplay tags, and with the gameplay tags specify what's happening with a certain tile. Is there a building on it? Is it owned by somebody? Things like that. So if you're familiar with gameplay tags, you can definitely do something like that. Now for this example, I want to create a simple second structure. So I'm going to go back to the grid folder, right click, go to blueprint and create another structure. Call this s_grid information, and in this structure you can save all kinds of things that you want to know about a certain tile. So for example, put a boolean in there, has building, and then we can, that's a little spelling error, oh really, and we can add another variable that says building name, for example. Oh freaking, and then change this into a name, and we could add something like the owning player or the owning actor. So owning player, and then turn that into an actor or a character variable in your game or something like that. So just for example, I'm going to use this simple structure. Then in our grid manager we can map the coordinates to our structure that we just created. So that's the grid information structure. Compile and save it. And now that we have this one in place, we can go back to our top-down controller, and we can say if we left click, we want to get information about the current tile. So let's get rid of all of this annoying stuff that we're not using. So we need to get our grid manager from the components, and from here we're going to get our grid information. So that's the mapping that we just created. And we also need to get the current grid coordinate. So get grid coordinates. So this is where our cursor currently is. Then we can drag off the mapping and we can find the current coordinate. So plug that in over here into the mapping node. Let's grab a branch in here. I'm going to use the started pin and then simply plug in the branch into the condition. So if this is false, there is no entry in the mapping for this coordinate. So then we can add a little print that says no tile info found, for example. And let's make this a different color so we can identify it. And if we actually do find something, then we can drag off the structure and we can break it. And for example, we can print our building name that's on the current tile. So let's grab another print string and simply plug in the building name like so. And then if we right click, I want to actually add a building to that tile, for example. So I'm going to go to right mouse button. So I'm not going to use inputs. I'm simply going to use a little mouse event in here. And if we right click, we want to quote unquote build something on this tile. So again, we're going to grab our grid manager and we can get our grid coordinates. And we also want to get our grid information. So that's the mapping. And we want to get it like so. And we drag off the mapping and we can add an entry in here. So if we press, we want to add an entry and we want to add our grid coordinates over here. So this is the entry, and then we can make a grid information structure. And for example, we can say we want to build a house over here. And so, yeah, for this example, that's all we're going to do. But you can make it so the building name is linked to a certain data table that will get information, or use primary data assets, for example, to actually set up stuff over here. So to get the correct actor that you want to build or whatever you want to do. And then if I shift and right click, I want to get rid of the building. So let's copy and paste this node and I'm going to say shift over here. And then we can simply remove an entry from the mapping as well. So if we get our grid information mapping, we can say remove. And again, we need to get the grid coordinates that we want to remove. So get those as well and plug them in over here into the pressed pin. So now if we right click, we quote unquote build a house over here. If we shift right click, we get rid of the house. And if we simply left click, we will get current information about the tile. So let's compile and save, hit play. So if I left click over here, no tile info found. If I right click, it should build a house, but we don't see anything. But if I left click, then you will see on the top left, we have a house on this tile. And then if I hold shift and right click, it will actually get rid of the house and there's no tile info found. So that's something that you can pretty easily use to define what's happening with a certain tile, because this grid coordinate is always unique. And if you want to, you can add a Z value as well if it's needed for your project. So that's pretty useful. Let me go back to the top-down controller, select our grid manager, and I'm going to go back to a 100 grid size. And then let me show you one little quick example where you can use this as well. So for example, if we go to our project settings, we can add a new collision channel. So go to collision over here, add a new object channel, and let's call this something like selectable. So you can assign this to every selectable thing in your game, or add a box collision that has this new object channel. So by default, I'm going to say ignore it and then create the object channel. Now let's create a simple house. So I'm going to create a blueprint class that's simply going to be an actor and call this BP_house. Open it up, and in here we're going to add a little cube. So first of all, let's make it a bit smaller. I'm going to say 0.5, 0.5. Oh, that's not good. 0.5, 0.5, and then 0.75. And let's give it a brick texture so it looks a tiny bit like a house. There we go. And make sure it's not inside of the ground, so I'm going to raise it up a little bit. There we go. And then with the cube selected on the right side, we want to go to the collision settings over here. And instead of block all dynamic, we're going to say custom and then change the object type to our new selectable object type. So we can identify it over here. Compile and save. And then if we go back to our top-down controller, now let's make it a little bit easier to follow. So first of all, let's go into our grid manager. And we actually want to add a little thing to our event tick over here. So I'm going to create a little bit of room, drag off, and I'm going to add a sequence node. So first we're going to do the things that we already did. And then I'm going to drag off the player controller again, and I'm going to get the hit result. But this time I'm going to get it under cursor for object, so we can actually look for object types. If we drag off the object types over here, we can make an array. And then we can change this to our new selectable object type. Then we're going to drag off the hit result and we're going to break it, expand this. And over here we get the hit actor. So this will only detect actors with the selectable object type as a collision. So then first thing we can do is drag off here and check if this is valid or not. So grab the one with the question mark. And I'm going to plug that into the sequence node over here. So if it's not valid, I'm going to grab our player controller and set the mouse cursor. And use this enumeration one. So set the mouse cursor and set it to default. And then copy and paste this. And if we do have a valid hit, make sure we plug in our player controller. Then I'm going to say I'm going to want to use the grab hand cursor. Then we want to drag off the hit actor again and promote it to a variable. And this is actually our overlapped actor, for example. There we go. So this goes into the is valid pin, and then we want to remove it if we don't have a valid actor. So then if it's not valid, we're simply going to set it to an empty reference and it's not valid anymore. So compile and save, and then in our top-down controller again. So if we go to the building of the house, so that's the right click over here, we can say spawn an actor from class. And we want to spawn our BP house. So the spawn transform, we want to split the struct pin and then drag off the grid manager, and we need to get the grid location. So that's the location where we want to spawn our house. And then if we want to remove the house, we want to move this to the side a little bit, because first we want to check if we had a valid actor. So we're going to drag off the grid manager and get our overlapped actor. Drag off and check if this is valid. Like so. And if it's a valid overlapped actor, then we can delete it. So we can say destroy actor. And then remove all of the tile information, like so. So now if we compile and save and hit play, so if we right click, we will spawn our house. And then if we left click on it, we will get the house information. Left click on an empty tile, there's no tile info found. And as you can see, the mouse cursor changes if we hover over the actual actor. And if we hold shift and right click, the actor will be removed. And then again, there's no tile info found. And at this point, you will see the marker actually go up and down. And that's simply a matter of setting the collision. So if we go to our BP house, we could say for the visibility response, ignore it, compile and save. And then the actual cursor stays on the ground. So you probably want to create a new trace channel for that, so you can define what actors you want to trace to and which actor you don't want to trace to, in the same way as we did with the selectable object channel, for example. So yeah, that's pretty much how it could work. And you can use this in a pretty versatile way. So for example, you can make a parent-child blueprint setup where your parent is selectable, and then simply make child blueprints, add an interface to those, and if you click on them, you can make them selected, highlight them, get information from them, and all that kind of stuff. So I hope this makes sense, and I hope you guys think it's useful. If you do, please consider leaving a like, and again, you can go to the Discord and download all kinds of free projects from there. So if you want to check out the example arcade racing project or anything else, just dive into the Discord. Thanks for watching, everybody, and talk to you later. Bye bye.